Hello everyone. Let's continue our discussions about differentiation. I asked you all to try out the sums of exercise 5.1. Let's quickly go through them. Exercise 5.1 ML. Question number 1. Y cube minus 3xy square equal x cube plus 3x square y. Can we separate the variables here? Is it possible to separate x or y?
No.
No. So let's differentiate them directly, differentiating both sides with respect to x. So y cube becomes 3y square dy by dx minus 3. In xy square, we will apply product rule, leaving x. Y square becomes 2y dy by dx plus leaving y square, x becomes 1. X cube 3x square plus 3 x square y, again product rule, leaving x square y becomes dy by dx, leaving y x square becomes 2x. All the terms have 3, so we can take it common and cancel out. Y square dy by dx minus 2xy dy by dx minus y square equal x square plus x square dy by dx plus 2xy. So now the terms that contain dy by dx, let's keep them on one side, and the ones that don't contain it, keep it on the other. So y square minus 2xy minus x square, taking dy by dx common in those selected terms. Rest of the terms without dy by dx on the other end. So dy by dx, isolating it. If we want, we can may write this x square plus y square plus 2xy as x plus y whole square divided by y square minus 2xy minus x square. Does it match?
Yes, ma'am.
Second
Yes.
question. X plus y whole square equal to axy. You can directly differentiate or open the whole square first. So x square plus 2xy plus y square equal to axy. Differentiating both sides with respect to x. X square becomes 2x, leaving 2. In xy, let's apply product rule. So y becomes dy by dx plus y, x becomes 1. Y square 2y dy by dx equal twice say. In xy, we will apply product rule. So y becomes dy by dx plus y, x becomes 1. Now again, each of the term has 2. Let's take that common and cancel out. X plus x dy by dx plus y dy by dx equal ax dy by dx plus ay. Similarly here, all the terms that contain dy by dx, we bring them on one side and take common. So taking dy by dx common, x plus y minus ax without dy by dx on the right hand side. So from here, dy by dx will be ay minus x minus y by x plus y minus a. Yes?
Yes, ma'am.
Third, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals 0. Instead of x and y, whichever letter you see are all constants. Differentiating both sides. Leaving x square becomes 2x. Leaving 2h. So xy will be x dy by dx plus y into 1 plus b. Y square becomes 2y dy by dx plus 2g plus 2f, y becomes dy by dx, c becomes 0. Again, all the terms have 2. Let's remove them. Ax plus hx dy by dx plus hy plus by dy by dx plus g plus f dy by dx equals 0. Now, all the terms that contain dy by dx, let's take common. So, hx plus by plus f dy by dx equal minus ax minus hy minus g. So, dy by dx, taking minus common in the right hand side, ax plus hy plus g divided upon hx plus by plus f.
Yes, ma'am.
Rest of you, all of you done?
Yes, ma'am.
Next, fourth one. 3x minus 2y equal log 3x plus 2y. Differentiating it directly, 3x becomes 3 minus 2, y becomes dy by dx. On the right hand side, we will apply chain rule. We will treat this as log x. So log x is 1 by x, and then differentiating this particular term. So this would be 3 minus 2 dy by dx equal 1 by 3x plus 2y. This would be 3 plus 2 dy by dx. Any doubt till here?
No, ma'am.
Lakshita, Shiba, you just
No, ma'am. No,
No,
ma'am.
cross multiplication. 3 minus 2 dy by dx into 3x plus 2y. 3 plus 2 dy by dx. So 9x plus 6y minus 6x dy by dx minus 4y dy by dx equal 3 plus 2 dy by dx. So all the terms that contain dy by dx on the one side and all the rest on the other. So 9x plus 6y minus 3, 2 plus 6x plus 4y dy by dx. I can again take 3 common here. 3x plus 2y minus 1, taking 2 common. 1 plus 3x plus 2y. So 3x plus 2y minus 1 divided by twice. 1 plus 3x plus 2y equal dy by dx. Does it match?
Yes, ma'am.
yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Fifth
ma'am.
one, e power x minus y log of x by y. So it is possible to simplify it a little. So log x by y can be written as,
Log x minus log y.
which helps reduces this, otherwise you would have had to apply chain rule. Now differentiating it. Ex is ex. Because of chain rule, I need to differentiate the power again. Log x becomes 1 by x. Log y becomes 1 by y dy by dx. Now, e to the power x minus y, 1 minus dy by dx. 1 by x minus 1 by y dy by dx. Opening the bracket, e power x minus y minus e power x minus y dy by dx. 1 by x minus 1 by y dy by dx. So the terms that contain dy by dx, those on the one side and the rest on the other end. So 1 by y dy by dx minus e power x minus y dy by dx. 1 by x minus e power x minus. Taking dy by dx common, 1 by y minus e power this Taking LCM here. Again, taking LCM in the bracket. 1 minus y e power x minus y by y. 1 minus x e power x minus y by x. So dy by dx. Y into 1 minus x power e power x minus y. X 1 minus y e power x minus y. Very complicated answer, but in differentiation, you usually get answer if you're a little patient and just wait a little. Any doubts still here?
No,
No,
ma'am.
mom.
No,
Now,
ma'am.
moving to the proof that questions. In proof that questions, we need to look at the proof that and proceed accordingly. For example, in question number 6, given xy cube equal to 1. If you look at the proof that, in the proof that there is no x, that means I should differentiate in such a way that x vanishes, right? Or then otherwise you have to do substitution and all, which is a little difficult, right? So in order to, right now, if I would have differentiated, I have to apply product rule. If I apply product rule, x will remain. So trying to avoid that, I'm doing what? I'm isolating x here. Because if I would have taken x on the other end, 1 by x, then while differentiating 1 by x, x will not vanish. So in order to make x vanish, I've isolated x in the numerator on the left side and brought y on the other end. Is it understood?
Yes,
Yes,
ma'am.
mom.
Now
Yes, ma'am.
differentiating it, x becomes 1. What about 1 by y cube?
Will it be minus 3y to the power minus 4?
3 upon y power 4 dy by dx. Cross multiplication, y power 4 equal minus 3 dy by dx. So 3 dy by dx plus y power 4 equals 0. Yes?
Yes, mom.
Yes, ma'am.
All of you understood?
Yes, ma'am. Yes, ma'am.
Yes,
So
ma'am.
whenever there's a proof that question, we need to be very careful. We can't directly just jump on to differentiate. You need to plan. Something similar in 7. Given under root y plus x plus under root y minus x equals c. If you look at the proof that dy by dx equal y by x minus under root this. So when I saw the proof that, I looked at this term. This is y square minus x square by x square. So how can I get this term from the given? How can I get this term from the given? If I differentiate directly, there will be 2 root over sign. There's no point. Maybe, but it's better to do one more thing. What should I do? When you see root over, what's the first thing that comes to mind?
Squaring on both sides.
Squaring on both sides. So, under root y plus x plus under root y minus x whole square. So, a square plus b square plus 2ab equals c square. So 2y plus 2, I can multiply them. A square minus b square. Can I take 2? Divide everyone by 2. Becomes a little easier. Why did I do that? So that when I differentiate, 2 also becomes 0. Right? It becomes a little simpler. Is there any doubt till here?
No, ma'am.
Let's
No, ma'am.
differentiating both sides. Y becomes dy by dx. Now, this will be treated as root x Root x is 1 upon 2 root x into differentiation of y square minus x square. This will be 0. So dy by dx plus 2y dy by dx minus 2x whole thing divided by twice y square minus x square equals 0. Is it okay?
Yes, ma'am.
Taking 2 common and cancelling out y dy by dx minus x upon under root y square minus x square. Taking whole LCM, so under root y square minus x square into dy by dx plus y dy by dx minus x equals 0. So the denominator can go to the right side, and taking here dy by dx common, y plus under root y square minus x square minus x equals 0. Shifting it to the other end, dy by dx into y plus under root y square minus x square equal x. Again, dy by dx, x divided by y plus root over y square minus x square. Is this what we wanted?
No, mom.
No,
There is
ma'am.
no denominator there, right? So what can be done here? We can rationalize this.
Yes, ma'am.
Yes, mom.
So in the denominator, we have a plus b, multiplying it by a minus b. Similarly, in the numerator also a minus b. Numerator remains as it is. Denominator a square minus b square dy by dx. So denominator is x square. One of the x gets cancelled. Y minus under root y square minus x square by x. Looking at the proof that we can isolate them individually, divide them. Now, what is under root x square?
X.
So I can write x as under root x square. I can take x inside the root over. Now, again dividing them individually. Y square by x square minus x square by x square 1. Isn't this what they wanted us to prove? Clear?
Yes,
Yes,
mom.
ma'am.
Any doubts?
No, ma'am. No, ma'am.
Written?
1 minute, ma'am. Yes, ma'am. Done.
The number 8. Number 1. Y square equal 4x. We want to find first dy by dx. So we will differentiate with respect to x. Differentiating both sides with respect to x. So ddx of y square equal d dx of 4ax. Differentiation of y square is 2y dy by dx. Leaving 4a, differentiation of x is 1. So dy by dx equal 2a by 1. Any doubt?
No, mom.
No.
Mom.
Now, if you look at the proof, we also want dx upon dy. So in this case, we will treat y as the variable.
Yes, mom.
We are going to
Yes, mom.
differentiate both sides with respect to y. Differentiating both sides with respect to y. So
Ma'am,
d dy, sorry,
ma'am, I have a doubt.
yes.
Since in the proof it already states we need dx by dy, why didn't we just differentiate from the starting with y?
We also want dy by dx. No? There are two things.
So the order doesn't matter.
I didn't understand.
Like you can do first you can differentiate with x and then you can differentiate with y, or you can do both ways.
Yeah, that doesn't matter. While multiplying, I'll do it. Anyways, it was written for dy by dx only.
Okay, ma'am. Yeah, got it. Sorry.
But in any which way, the order
Okay.
doesn't matter. While multiplying, multiply any which way.
Okay, ma'am.
d dy of 4ax. So what will be differentiation of y square with respect to y?
2y.
2y, that's it. Here leaving 4a, differentiation of x with respect to y will be dx by dy. Yes?
Yes, mom.
So y by 2a. In general, since this question was actually about proving the same thing, later on in a normal scenario, we can just reciprocate. If dy by dx is 2a by y, dx by dy will be reciprocal y by 2. You can directly do it. But this particular sum was meant to show that. That's why I'm showing both the cases. Otherwise, in general, you can just reciprocate.
Okay, mom.
Now, dy by dx into dx by dy. This is 2a by y. This is y by 2a. Cancelling 1. Yes?
Yes, mom.
Any
Yes,
doubt?
mom. No, mom.
Similarly, second one. X cube plus y cube equal 3axy. Let us first differentiate with respect to x. d dx of x cube plus y cube. Differentiation of x. So x cube is 3x square. Y cube is 3y square dy by dx. Try say applying product rule. Leaving x, y becomes dy by dx. Plus leaving y, x becomes 1. We can cancel out 3. X square plus y square dy by dx. Ax dy by dx plus ay. Bringing dy by dx on one end. Y square minus ax equal ay minus x square. So dy by dx ay minus x square y square minus ax. Yes?
Yes, mom.
Now repeating the same thing with respect to y. Again, x cube plus y cube equal 3axy. Differentiating with respect to y. X cube 3x square y cube. Is it okay?
3x squared dx by dy.
Thank you. Y square is 3y square thrice a We have to apply product rule here. 3 goes away. X squared dx by dy plus y square a, leaving x 1, leaving y becomes dx by dy. Opening the bracket, x squared dx by dy plus y square ax plus ay dx by dy. Bringing dx by dy on one side, x square minus ay dx by dy equal ax minus y square. So dx by dy equal ax minus y square upon x square minus a1. Any doubt?
No, ma'am.
No, mom.
Now dy by dx into dx by dy. So dy by dx was this case. And this is dx by dy. So, okay. Taking minus common here, x square minus ay. Taking minus common here, ax minus y square. Now it gets cancelled. And minus minus is plus 1. That means in every single scenario, if you have obtained dy by dx, you can just reciprocate and write dx by dy. Don't need to do it again and again.
Okay, ma'am.
Okay, ma'am.
Everybody clear?
Yes, ma'am.
Yes,
Yes, ma'am.
Now, in order to do 9, we are moving on to a new variety, that is infinite terms. So as it says that if I have an ocean, I remove a bucket of water, it doesn't matter. Similarly, here, if you see the pattern in question 9, I have written y as under root x plus. Again continuing the pattern, under root x plus. Again continuing the pattern, under root x plus. And this goes on to infinite times. Yes? So y is infinite times under root of x plus. So from that, if I just remove one of the term and I consider this. So if something was going infinite times, from that I removed this particular one pattern. So the one that I have shaded, isn't that again y?
Yes,
If
ma'am.
y was infinite times under root x. So from infinite times, I took one of it outside. It doesn't matter. So again, the one that I've shaded is the same pattern and continuing. So I can name that again as y. Can I do that?
yes, mom.
Yes, ma'am.
Everybody?
Yes, ma'am.
Yes, ma'am.
So squaring both sides. Y square equal x plus y. I can isolate the variables on one side. Now differentiating both sides with respect to x. Y square becomes 2y dy by dx. Y becomes dy by dx. X becomes 1. Taking dy by dx common, this is what they ask us to do. Any doubt?
No, mom.
No, ma'am.
Will you try this? Same. Y is equal to x plus 1 by x plus 1 by x plus 1 by infinite times. Find dy by dx. Done?
Ma'am, is the answer y by 2y minus x.
Let's see. What did you do?
Ma'am, I took 1 by x plus pura infinity as x plus 1 by y.
So this particular form is again the same pattern. X plus 1 by x plus 1 by. So I can write that as y.
Yes, ma'am.
Bringing the y's on one side. Let's differentiate. Differentiating both sides with respect to x. Y becomes dy by dx. 1 by y is minus 1 by y squared dy by dx. X is 1. Taking dy by dx common, 1 plus 1 by y squared. You can leave here or just take LCM. Y squared plus 1 by y squared dy by dx equal 1. You can leave at any step.
Ma'am, can you explain how you got that x plus 1 by y again?
So what was y? Y was x plus 1 by, again x plus 1 by, again x plus 1 by. This pattern continued infinite times. So if I remove this one pattern, it's the same thing going on. So this is again the same y pattern. Yes or no? X plus 1 by, x plus 1 by. So I only removed one x plus 1, one time. So again in the denominator, the same pattern and continues till infinity. So that term can be written as 1.
Okay, ma'am.
With the infinite pattern, you remove the pattern once. Clear?
Yes, ma'am.
Now, before moving forward, there's a sum in the example also, example 2 just before this. And it's a very important sum. Question. If x under root 1 plus y under root 1 plus x is 0, then prove that dy by dx equal minus 1 by 1 plus x whole square. Now, this is a proper learn sum. If you don't do it in a certain pattern, you won't get the answer. If you just directly differentiate, you will not get the answer. Impossible. Right? So if you notice, in our question, there is both y and x which cannot be isolated. But in the proof that there is no y. In the proof that there is no root over. So we want to remove the root over. To remove the root over, what should we do?
Square on both sides.
But if I do the squaring right now, in the twice AB term, I will still have root over. So before squaring, what should I do? Since the right hand side is 0, take a term to the other side, any term. And now if we square, then the root over will vanish from both the terms. Yes or no?
Yes, ma'am.
Yes, ma'am.
So square it, multiply it. Start. Square it, multiply it. X square, 1 plus y. Y square, 1 plus x. X square plus x square y minus y square minus xy square 0. Let's factorize. So these two terms looks like similar and the other two terms. We have to factorize. So x square minus y square can be written as
X plus y into x minus y.
and in the other two terms I'm taking xy common. Again taking x minus y common. So if product of two number is 0, then one of them has to be 0. Either x minus y is 0 or x plus y plus xy is 0. From here, we get x equal to y. But if you see it in the question, it is written that x is not equal to y. In the example, if you see, it is written that x is not equal to y. So that means this is not possible. Yes, that means definitely the second term is true. So what we have done till now is from such a complicated equation, we have come to a simpler equation, right? Now again, can I separate the variables here? Yes, if you take y common in these two terms and the single x on the other, y is minus x by 1 plus x. What will happen now is as soon as I differentiate, there will be no y term on the right hand side in the answer. Did you see?
Yes, ma'am.
Yes, ma'am.
Understood why I did it? If you would have done it directly, then you would have got y in the answer. But if I do it now, you won't have y in the answer.
Yes, ma'am.
So differentiate now. You'll have your answer. Differentiating dy by dx, leaving minus outside. Quotient rule 1 plus x whole square. Leaving 1 plus x, x becomes 1 minus x. Differentiation of 1 plus x is 1. Minus 1 plus x minus x. So minus 1 by 1 plus x whole square. This is what was asked us to prove. Yes?
Yes, ma'am.
Everybody clear? It's a learn sum. If you haven't done earlier, you won't be able to visualize this. That's impossible. So that's why I said it's a learn. You have to do it. Done?
Yes, ma'am.
Now, a similar kind, not a learn category, but a little different. Example 4.
Ma'am, could you display the previous sum one for 1 second?
Just
Okay, ma'am. Thank you, ma'am.
everybody done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Example 4. xy into log of x plus y is 1. If the question would have been directly find dy by dx, you can do whatever you want. Differentiate directly. There are three terms. Note. Differentiation of u, v, w. Leave two, differentiate the third. Again leave other two, differentiate the third. Again leave other two, differentiate the third. So here there are three terms x, y and log. Out of left two, differentiate one, then again left another two, differentiate one, then again left another two, differentiate one. I would have done that and I would have been okay. But if it is only dy by dx, but if it is a prove that question, then prove that dy by dx equal minus y x square y plus x plus y x xy square plus x plus y. Can you see a logarithm term in the proof that? Do we have log term in the proof that?
No, ma'am.
No. That means when you differentiate, there should be no logarithm term. But if I would have applied directly your product rule, then I will definitely have log. That means you can't differentiate directly. So what should I do? What should I do so that when I differentiate, log vanishes?
Take log on both sides.
No, there's already a log. If you take log on both sides, it's even complicating it more.
Take it to the other side and make it e power,
Which term?
the log term.
Okay, one sec. If I take the log term here, I will treat first as 1 by x. Then there will still be a logarithm in the answer. You should take xy to the other end. Leave log here. Because when I differentiate here, log x, 1 by x, and log goes away. Yes or no?
Yes, ma'am.
Understood what I just said?
Yes,
See,
ma'am.
I'm not saying that we
Yes,
don't do
ma'am.
it in this way, you won't get the answer. No. It will be a little longer in the other case, but you will get an answer. So that's why I'm not saying that learn this. If you would have directly applied product rule, then after some simplification, substitutions, you will get this answer. That's not a problem. But if you visualize or prove that earlier, it becomes easier for us. Right? So right hand side, I can visualize them as 1 upon x into 1 upon y. Can I do that? So that I can apply product rule.
Yes, ma'am.
Let's differentiate both sides. So log x is 1 by x into differentiation of this term. Here applying product rule, 1 by x as it is, 1 by y becomes minus 1 by y square dy by dx plus 1 by y as it is, 1 by x becomes minus 1 by x square. 1 upon x plus y. This will be 1 plus dy by dx minus 1 upon xy square minus 1 upon x square. Let's multiply. 1 by x plus y plus 1 by x plus y dy by dx minus 1 by xy square minus 1 by x square y. So in these two terms, let's take dy by dx common. The other two terms there. LCM x plus y xy square. Taking minus common, now taking LCM. So from both the sides, we can cancel x plus y, x plus y. We can also cancel 1x and 1y from the denominator. Yes.
Yes, ma'am.
Now shift everywhere. Dy by dx minus y. Denominator, I already have an x square y plus y upon xy square plus x plus y. It matches. It matches with the proof that. Done?
1 second, ma'am.
No problem.
Ma'am, can you explain where the minus y by x came from again?
Here 1y will remain and here 1x will remain. So this 1y goes to the top and that x comes to the denominator.
Okay.
Done?
Yes, ma'am.
Yes, ma'am.
Yes, mom.
Yes,
Any
ma'am.
doubts still here?
No, ma'am.
No, mom.
Okay. Now we'll
No,
move
ma'am.
on to a new variety. We'll move on to a new variety. You all are comfortable with logarithm, right? I explained you in the initial day classes, logarithm properties, log a b, log a by b.
Yes, ma'am.
Yes, mom.
Yes, ma'am.
We are going to start with a variety that is variable to the power variable. So see, we have differentiated these terms. Variable power constant. What is the differentiation of x power 4? Or rather x power n?
And
And
next to
next
the power n minus 1.
We have differentiated these term constant to the power variable nx power x. The formula was n power x log n. 2 power x was 2
yes,
power x log 2. So n power x will be n power x log n.
yes, mom. Yes, mom.
So we have done a combination of variable and constant, whoever can sit at any place. Now we are going to do variable power variable. Variable power variable can be done in two ways. Using logarithm or using e. You all remember this property. What is e power log x?
X.
If nothing in the base, that means e. So e log e gets cancelled and we get x. This is what we'll be using here. Okay. So when can we apply the what? Let's first understand. In singular terms, both of them can be applied whichever you want. Singular term, in single terms, you can apply any which way, whatever you want. There is no restriction. Yes? For example, x to the power x. Basic, classic variable power variable, the most basic one. If they have given it a name, perfect. If they haven't written a name, give it a letter. Let y equal this. Okay? First showing you the logarithm way. Taking log on both sides. You need to know both the methods. Both the methods have to be known. So this is log y. This is log x power x. Log y. Power comes to the front. X log x. Yes?
Yes, yes, mom.
Differentiate
Yes, ma'am.
both sides with respect to x. Differentiate both sides with respect to x. Log y, 1 by y dy by dx. X, log x becomes 1 by x. Log x, x becomes 1. 1 by y dy by dx. 1 plus log x dy by dx. Y into 1 plus log x. So y was what? X power x. Substitute it again. So that's our answer.
Yes, mom.
Any doubts here?
No, ma'am.
No.
Okay. While using E, what we will do? First understand that. See, e power log x can be written as x. So what I'll do is I'll write it in a complicated manner. If there is a term here, I'll write it in this format. E power log and whatever the term was, I'll write it there. If I would have had x square, I'll write e power log x square. If I have x cube, I will write e power log x cube. Just for some reason. Okay, humor me. So here the same sum using e. Y is x power x. So on the right hand side, deliberately I'm writing e and log. This was the term I had. I'm writing it x power x. They are same. This term and this term is same. It's just the outlook has changed. The way they look has changed. Is this line understood? Whatever is the term, just write after log.
Yes, ma'am.
Yes.
Yes,
Yes,
ma'am.
Now y equal e. The power comes to the front of logarithm. So e has power x log x. E has power x log x. Now I'm differentiating it both sides. dy becomes dy by dx. Right hand side, I will treat it as ex. I will treat it as e power x. Can I do that?
Yes, ma'am. Yes,
So
ma'am.
differentiation of e power x is e power x. Then chain rule. So dy by dx e power x log x. Product rule. Leaving x, log x become 1 by x. Leave log x becomes 1. Now, this term can again be written as x power x. They were same now.
Yes, ma'am.
So, dy by dx is equal to x power x into 1 plus log x. Every single time you'll get the same answer, that is not necessary. You may have a different answer. Right? In this case, you got the same answer from both the methods. In some cases, you may not. And it's not a choice to learn one method because in some, like in this situation, you can use anyone. That's your choice. But in some cases, you can only use one of them. In some cases, you can use the other one. You need to know both the methods.
Yes, ma'am.
Let's try one question. Y equal x power y. Try it from logarithm first. Use logarithm and find dy by dx. Use logarithm and find dy by dx. Have you done it?
Yes, ma'am.
Yes,
Okay,
ma'am.
check. Taking log on both sides. Y becomes log y, log x power y, log y comes to the front, differentiating both sides. Log y is 1 by y dy by dx. Here applying product rule, y log x is 1 by x, log x, y is dy by dx. Any problem till here?
No,
No,
ma'am.
ma'am.
Now, both these terms that contain dy by dx, let's bring it to one side. 1 by y minus log x dy by dx equal y by x. Taking LCM, 1 minus y log x by y equal y by x. So, dy by dx, y square by x, 1 minus y. Here, there's no need to again replace y. You can leave it as it is.
Yes, ma'am.
Did you get this answer?
Yes, ma'am.
Yes, ma'am.
Try the same sum using e.
Ma'am, why do we not have to replace the y with x power y?
It will be a complicated term, x power y. What's the point?
So we can
If
leave
it's
it.
a proof that, then it is necessary to write in a certain way. If it is not a proof that, then it's your choice. Even if you do it, it's okay. If you don't do it, it's
Okay.
okay. Try the same sum using e. Have we done it?
Ma'am, is the answer y squared by x into 1 minus y log x?
Yeah, it's the same answer only. So
Okay.
y here e power log, just copying this term here as it is. So y equal e power, y comes to the front, differentiating both sides. Dy by dx. Ex becomes ex. Applying chain rule to y log x term. So dy by dx. Writing this term again as x power y. Or we can also write this as y. Right? X power y is same as y. You can write this as x power y also. You can write this as y also. Okay?
Yes, ma'am.
Applying product rule here. Y into 1 by x plus log x into dy by dx. If I write here y, dy by dx, y square by x, y log x dy by dx. Bringing the dy by dx term on one end. 1 minus y log x equal y square by x. Shifting it. So dy by dx, y square by x, 1 minus log x. You could have also written x power y also. It's the same thing. Any doubt?
No, ma'am.
No.
Okay. Now, if there are sum of terms here, if there are sum of two terms, then we have to apply E. And if it is product of terms, product or division of terms, we will use logarithm. Why? If suppose y is a into b, then applying log makes sense. Because if I write log ab, I can expand it and say log a plus log b. There's a property. But if I say y is a plus b and I would have taken log here, you can't apply individually. This will be log a plus b, which will make it even more complicated. So when there is a plus or minus sign between the terms, we will be using E on individual terms. And if there is a product or division of terms, we'll be using logarithm. Yes?
Okay, ma'am.
For example,
Yes, ma'am.
question y is x power x plus log x. There is a plus in between and there is only one variable per variable term. So we will apply E only in this term. That's the flexibility here. We will apply E only and only on the variable per variable term. So y e to the power log x power x. Power comes to the front. Now we can differentiate this. Differentiating both sides. Y becomes dy by dx. Ex becomes ex. Applying chain rule here. Leaving x, log x becomes 1 by x. Leaving log x, x becomes 1 by x. Plus log x is 1 by x. Any problem in this line?
No, ma'am.
Ma'am, won't it be log x into 1?
Sorry?
Ma'am, won't it be log x into 1?
Oh, yes. Thank you. Now, this will be x power x into 1 plus log x plus 1 by x. If you want to take LCM, take it, but there will be no more simplifications after. So you can leave it as it is also.
Yes, ma'am.
Yes, ma'am.
Now, if there is a multiplication term, y equal x power y into y power x, using e will not help us. It's going to be complicated. It's easier to take logarithm here. So, taking log on both sides. Log y, log of the whole thing. Log y. So first log AB, log A plus log B. The power comes to the front. Y log x plus x log y. Now differentiate. Log y is 1 by y dy by dx. Leaving y, log x becomes 1 by x. Leaving log x, y becomes dy by dx. Differentiating this term, leave x, log y becomes 1 by y dy by dx plus leave log y, x becomes 1. So 1 by y dy by dx equal y by x. Okay. So the terms that contain dy by dx, we can bring them on one side. 1 by y minus log x minus x by y dy by dx. And the terms without it, y by x plus log y. Take LCM on both sides. Taking y here, 1 minus y log x minus x. Here, taking LCM x, y plus x log y. Shift dy by dx, y into y plus x log y divided by x into 1 minus y log x minus x.
Yes, ma'am.
Sometimes answer may look like there is no right way, but trust yourself and be confident about it.
Yes,
Now,
ma'am.
the same logarithm can also be used when there are a lot of terms. For example, we all completed the previous sum.
Yes, ma'am.
Y is x square plus 1 whole cube, x minus 1 power 4, x cube plus x to the power 2. When there are so many terms, here also you can use logarithm. So, taking log on both sides. Log y here, log of the whole thing. So in log, whichever number, log AB opens up as addition, log A plus log B. Log A by B division opens up as subtraction, log A minus log B. So log y, log x square plus 1 whole cube plus log x minus 1 to the power 4 minus log x cube plus x power 2. The powers come to the front. 3 log x square plus 1 plus 4 log x minus 1 minus 2 log x cube plus x. Let's differentiate. Log y becomes 1 by y dy by dx. 3 log x is 1 by x. And this was the term instead of x. So by chain rule, we get 2x. 4 log x 1 by x. By chain rule, we get 1. minus 2 log x is 1 by x. From chain rule, we get 3x square plus 1. So dy by dx equal y 6x by x square plus 1 plus 4 by x minus 1 minus twice of 3x square plus 1 by x cube plus x. You can leave here, or the only other thing that we can do here is put the value of y and then again this particular term here. That's it. Nothing else to do. Nothing else to do. You can do this. That's the only thing else you can do. Leave it here.
Yes,
So if
ma'am.
there is variable power variable, we can use logarithm or exponential. If it is a singular term, your choice. If it is plus addition or subtraction of two terms, you have to use e. If there is a product or division of terms, you have to use logarithm. Is it understood?
Yes,
Yes,
ma'am.
ma'am.
Any doubt?
Ma'am, can you show one more example using the E?
The subtraction or somewhere?
Yes, ma'am.
Okay, suppose y is x power y minus y square. Or if you want this also, then y power x. Let's take e power log x power y minus e power log y power x. So powers come to the front of logarithm. Y log x minus e power x log y. Differentiating both sides. Y becomes dy by dx. Ex is ex. So applying chain rule here. Y into 1 by x plus log x into dy by dx minus ex is ex. Let's apply product rule here. X log y is 1 by y dy by dx plus log y x is 1 dy by dx. This term can again be written as x power y. This term can again be written as
Y power x.
now let's open the bracket so that I can later take dy by dx common. Can you tell me what will I get if I simplify this? Y will be y, but same base divide. Power will get subtracted.
Yes, ma'am.
X to the power y minus 1
Yes, ma'am.
plus x power y log x dy by dx minus multiply this. What should I write?
Y power x minus 1.
Into x dy by dx minus y power x log y. Now take common. Dy by dx, dy by dx, dy by dx. 1 minus x power y log x plus y power x minus 1 into x. Y into x power y minus 1 minus y power x log y. Just shift. Y into x power y minus 1 minus y power x log y. 1 minus x power y log x plus y power x minus 1 into x. It became a little too complicated. You don't need such a complicated one. Is it understood now?
Yes, ma'am.
Yes, ma'am.
All of you clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
That's the end of today's session then.